Sometimes, no matter how well you design your code, there are still going to be changes that need to be made. It's difficult, if not impossible, to get it right the first time. That's where refactoring comes in. Refactoring is the process of making changes to your code so that the external behaviors of the code are not changed, but the internal structure is improved. This is done by making small, incremental changes to the code structure and testing frequently to make sure these changes have not altered the behavior of the code. Ideally, you do not want to do a refactoring overhaul once your code is complete. This could be time-consuming and may cause more issues than you're fixing. You want to be making these refactoring changes when you're adding features. Refactoring the code at this point can make the addition easier to achieve and saves you from needing a complete overhaul sometime down the line. So, what are these changes that you need to be making? Similar to the way we see patterns emerge in design, we also see patterns of bad code emerge. These are referred to as anti-patterns. Many of these anti-patterns are identified in the book Refactoring by Martin Fowler, where he refers to them as code smells. As a developer, this is a useful resource to have. Not only does the book describe these anti-patterns of bad code, but it also provides refactorings that you can complete in order to transform the code to improve the smell. The purpose of these code smells is to sniff out what is bad in the code. Similar to a drug-sniffing dog that you might see in an airport, you're going to learn how to sniff out these bad coding practices that are not supposed to be there. In the previous discussion, we asked you to discuss examples of bad code. I'm sure a lot of the examples that you pointed out we will cover in these lessons. Probably the most common example that comes up is in regards to comments. Normally, the issue is that code has no comments. This can be an issue for many obvious reasons. Having no comments makes it difficult for someone to understand what the code is doing, or should be doing. This could be another developer who's just joining the project, or a team member who might need to integrate some code. Or maybe it's even you, and you've forgotten how your code works. Having no comments is bad, but also having too many comments has issues of its own. They might get out of sync as the code changes. You might say that comments can be seen as deodorant for bad-smelling code. A lot of developers will try to cover up bad design by having a lot of comments that explain what the code does, or should do. Chances are, if you have a comment that describes a complicated design, you're covering up a bad design. You may also see reminder comments that say something along the lines of, "Don't forget to do this," or "If you make a change to this, make sure you update the code in this other method." These are also indicators of bad code. Using comments to explain a design could sometimes indicate that the programming language isn't appropriate. Perhaps the programming language does not support the design principles you're trying to apply, or maybe you're not using an appropriate programming language to support your designs. For example, in the early years of Java, the concept of generics did not exist yet. Developers previously would have to have comments to explain what they are doing with the code when casting types. Eventually, generics were built into Java, but until that time, many comments had to be used. This is a common occurrence in many young programming languages. Now that Java is a more mature language, you have no excuses. Now, don't get me wrong, I'm not advocating for no comments in the code. Comments are very useful for documenting the APIs, or application programmer interfaces, in your system, and also for documenting the rationale why a particular choice of data structure or algorithm was made. They also allow your code to be easily used by others. Like most things in programming, there's a balance you need to find, where you have effective comments in your code. The next code smell that we're going to talk about is duplicated code. You may have seen this in your own code, especially before you learned about object-oriented programming or design patterns. Duplicated code is when you have blocks of code that are similar but have slight differences. These blocks of code appear in multiple places in your software. Let's say you're working on a social networking website. A user can create textual posts that appear on their newsfeed, on a friend's wall, or in a group. You first create the ability to post on the newsfeed. These posts were visible by all the user's friends on their news feeds. Once that feature is complete, you then develop the code for posting on a friend's wall. Since you already have the functionality written for posting, you just copy and paste that code to reuse it for posting on a friend's wall. When you create the functionality to post in a group, you do the same thing. You just copy and paste that code for posting in a group. Now, as the website expands, you also want the ability to post pictures, and not just text. To add this functionality, you now have to update the code in all 3 places. What if you had other places in the code where a user could post? What if you missed one of those when you had to update the code to allow the posting of pictures? As you can see, if you would just combine the ability to post in one accessible method, all forms of post could use it. And when it came time to make a change, you would have just needed to update it in one location. This doesn't just apply to adding functionalities. You may need to update the algorithm or fix a bug. Having to update it in only one location will make it easier to implement the change and reduce the chance that you're missing a block of code that needs to be updated or changed. We talked about it earlier, but the DRY principle applies here. Don't repeat yourself. Now let's talk about the code smell of long method. This one is relatively self-explanatory. You don't want to have long methods. Having a long method can sometimes indicate that there is more occurring in that method than should be, or it's more complex than it needs to be. But how long is too long? It really depends. There's no magic rule that says that a method with X amount of lines is too long. For example, methods that set up a user interface tend to be naturally long, despite being focused on one specific task. This obviously depends on the toolkit being used. Generally, though, such methods aren't that complicated for their length, so a long method here might be okay. The code smell also could depend on the programming language. Smalltalk methods tend to be short, say about 15 lines on average. Designs in that language tend to have highly cohesive classes and methods, but also highly coupled. Some developers suggest that having an entire method visible at once on the screen is a good guideline, say no more than 50 lines of code. But there have been studies that programmers can handle methods of a couple hundred lines before they start to introduce bugs. Another matter is whether lines of code is even a decent measure of code complexity when figuring if a method is too long. Similar to having large methods, having large classes is also an issue. These large classes are commonly referred to as God classes, blob classes, or black hole classes. They just keep getting bigger and bigger. They normally start off as a regular size class, but as more responsibilities are needed, these classes seem like the appropriate place to put the responsibilities. But as one of these classes gets more responsibilities, these responsibilities tend to attract more responsibilities. And for convenience, where else are you going to put them but in this class? As you can see, just like a black hole, the class keeps getting larger and larger and keeps attracting more and more responsibilities. Eventually, you're going to need extensive comments to document where in the code of the class that certain functionalities exist. And again, comments can be an indicator of poor design, and this is no exception. To avoid this, you need to be explicit about the purpose of a class, and keep the class cohesive so it does one thing well. If a functionality is not specific to the class's responsibility, you may want to consider placing it somewhere else. Like I said, these large classes tend to grow exponentially, so it's better to catch on to this code smell early. Trying to break these up after the fact can be difficult and time-consuming. On the contrary, having too small of a class is also an issue. These are often data classes. Data classes are classes that contain only data and no real functionality. Generally, these classes would have getter and setter methods, but not much else. An example of a data class would be a 2D point class that simply contains x and y coordinates. Think about what the data contained in these data classes is being used for. Instead of just manipulating it with the getter and setter methods, is there something else they are used for that could be placed in this class? Consider looking at the other classes that are manipulating this data. Would some of their behaviors be better placed in one of the data classes? For example, with our 2D point class, you could have various transformation functions that move the point. If a class contains just data with getter and setter methods, it may not be a good abstraction or a necessary class. A related issue that we see is data clumps. Data clumps are groups of data appearing together in the instance variables of a class, or parameters to methods. Let's say we have a method that does something with integer variables x, y, and z. This method might look something like this. If we had many methods that perform various manipulations on such variables, it would make more sense to have an object as the parameter, instead of using these variables as parameters over and over again. In this example, we could use a 3D point object as the parameter, which contains the x, y, and z values. So the method would now look something like this. And we would have a point3D class. So now, instead of using the 3 data values as parameters, they are now stored inside an object, and that object can be used in their place as a parameter. You need to be careful here, though. You want to make sure that you're not just creating data classes like we talked about. You want these classes to do more than just store data. So you might decide that the original doSomething method, or a useful part of it, should belong in the point3D class. Like a lot of these code smells, fixing one code smell can sometimes lead to creating new smells elsewhere in the code. So if you're creating data classes in order to fix the data clump smell, you're also going to need to resolve the data classes smell by making sure the classes have effective methods, not just getters and setters. On a similar note, having long parameter lists is also a code smell. This is one code smell that needs some compromise. Having a method with a long parameter list can be difficult to use, which is bad. However, the common solution to reduce the amount of parameters is often to have global variables. These have issues of their own and generally should be avoided. Having a long parameter list can make the method difficult to use correctly. By having a long parameter list, you are increasing the chance of something going wrong. Generally, these methods require extensive comments to explain what each of the parameters does and what it should be. And as we've discussed before, comments are usually just deodorant for bad code smells. But what if they aren't commented well? Well, then you may need to look inside the implementation to see how they're used. This breaks encapsulation. So how do you win here? The best solution for long parameter lists is to introduce parameter objects. This is a common occurrence in graphics libraries. Sometimes there will be toolkits where they will pass in an object which gives the context for a graphics routine. So, instead of setting the details such as the pen color, line width, pen shape, opacity, etc. as individual parameters, you would just provide this context as a parameter object. So when the program needs to execute some drawing method, say draw circle, you don't need to pass in all the information about what the stroke should look like as individual parameter values.